Hello, good morning students. Today we will see the actual syllabus content, that is Unit 1 of our subject VLSI Design and Technology. Yesterday also, in earlier lecture, I have shown you what this particular unit is containing. This unit basically contains a language, and that language is VHDL. Before starting, we will just see the summary of the design flow for VHDL. Actually, whatever you are going to see over here on this slide, it is a VHDL design flow. It is actually the summary of VHDL design flow. Quite obvious. You can elaborate this also. The first block which you are going to see over here is a VHDL entry. Actually, as it is a summary, that's why it is directly showing the VHDL entry as one block. Before this, you can also bifurcate this block into the design requirement, the design specifications. Like that you can elaborate it. But quite obvious, it is a VHDL design entry, means you are writing a VHDL code for this and extracting the RTL level schematic for this. Whenever you are going to give this entry or write a VHDL code, that VHDL code gets synthesized. After synthesis, it will generate a netlist. You can have a gate level netlist, as well as you can optimize it and you can get an optimized netlist gate level. And after that, you can have a simulation to check does your circuit is working properly or not. If simulation is correct and if your circuit is working properly, then you will go for the next level, that is an implementation. Quite obvious, your implementation will be either on PLD or ASIC. Here the example is given for PLD, that is a physical device is being over there, and you will follow a procedure for implementation, that is a place and route, and your design will be implemented on a PLD, and after implementation also you can simulate your design and you will check that does your circuit is working properly after implementation. This is a very simple design steps which are being shown over here in a design flow. We have to study, actually in this unit we have to study the VHDL. That's why we will have a basic introduction of VHDL, what VHDL is. VHDL, in VHDL, the HDL stands for a hardware description language, and V, which is a first part of the VHDL, that V itself stands for VHSIC, where VHSIC stands for very high speed integrated circuit, and then you can add that HDL, which is a hardware description language. VHDL is IEEE standard, and this standard is a technology vendor independent language, and applications of this software are in FPGA, CPLD and ASIC programming. Whenever you talk about any language, quite obvious, we have to study a certain thing related to that language. That's why we will study what are the different things available in this language. The first thing, we will start from the data objects. In VHDL there are three types of data objects, that is a constant, variable and signal. Each of this type, whether it is a constant or variable or signal, is holding some value. Only there is a different types, such as a constant hold a value of a given type, and this value you can assign before simulation also. Before simulation you have to assign the value for the constant, and during simulation you can't change the value of this constant. Whereas if you go for a variable data object, this also hold a single value, but this value will be changed with the help of variable assignment statement. Similarly, there is a third category of data object is a signal. Signal is also holding a single value, but quite obvious, for signal this values may include the past values available on that signal, the current value of the signal, and which may be the future values which may be assigned to that signal. And the future values are assigned to the signal with the help of a signal assignment statement. Here one thing I want to tell you related to the signal, that if we see the signal data object, for the signal data object the language internally prepares a vector which will contain the present value, the past value, and a future values of signal. We will see one by one in detail. Signal, actually a signal has a analogy with wire. Signal has an analogy with wire, means whatever the thing which is being represented in case of hardware, the same thing is represented in a software, you may say in a language VHDL, with the help of signal. And you know that actually yet we have not started the actual structure of our VHDL. That's why here whatever I have written entity declaration, that entity declaration will be the actually the overview of your design or the interconnection of your design. That's why you can declare a signal in entity also, you can declare a signal in architecture also, and a package declaration in package also you can declare a signal. The syntax for a signal declaration will be like this. First you have to write a keyword signal, then signal name like A, B, C, D, any name you can give to the signal, and later on you have to define the type of the signal. You may assign initial value, and it is an optional, that's why it is written inside a square bracket, and after end there is a semicolon. An example, you can see that signal X colon bit and its initial value is 1. Here I want to tell you that the bit is a type. Bit is a type of the signal, whereas signal is an object. Similarly, second example which shows that signal A comma B is steady logic. Here two signals are being declared whose names are, names means I want to say the identifier, means they are being identified with the help of the name A and B, means signal they are declared as A and B and their type is steady logic. Now we will move to the variable. Variable, I told you that it is used for a local storage, can be used inside a processes and referred by that process only. These variables also declared in subprograms. We can see the syntax for declaration of variable. Here variable is also declared in the same type as that of signal, only the keyword is changing, and now the keyword is variable, and then variable name, variable type, you can assign the initial value for variable also. Here for example we have declared a variable y of the type is steady logic and its initial value is 0. Similarly, we will go for a last data object, that is a constant, and it is used for a specific value. You can declare the constant in entity, you can declare a constant in architecture, or you can declare a constant in package also. The syntax for constant is shown over here. Here we have declared a syntax for constant also includes the constant is a keyword of language, then constant name, the name which we are going to write, and again we have to define the type of constant. Here for example we have declared pi. Pi is a constant, the name of that constant is pi, and its object is constant, its type is real, and its initial value is 3.1414. Here we have seen constant has a single value and it is assigned before the simulation, whereas there is two things, that is a signal and variable, and there have certain difference. Okay, for assigning the values to the variable we will use a variable assignment statement. As for assigning the values to the signal we'll use a signal assignment signal assignment statement. And at a time variable can store a single value. Quite obvious, when it's stored it will take a less memory, whereas if you talk about a signal has to store its past value, its future value, and its current value also. That's why it will have a driver, signal driver. We may say a vector is being prepared which is name is a signal driver, and signal driver contain all these values. That's why definitely it will take more memory in the software. Next part, that is a data type, we will see in the next video.